All right, this video is kind of going to be a two-part video of related concepts. The first part, might not surprise you, is talking about infinite limits. And the second part is talking about asymptotes, okay? So let's start off with some lingo, which again, you may have seen before. It's a little intuitive, given what we talked about in earlier videos. If x approaches a from the left or from the right, and f of x approaches infinity. Ooh, that's a weird infinity. F of x approaches infinity. We write that the limit as x approaches a from the left of this function is equal to infinity. As a side note, the book writes positive infinity, which is a little redundant. And I don't like it, but some people do it. So if you see positive infinity, of course, it's just like 2 is equal to positive 2. All right, so you will see that, but I'm not going to be writing the positive part. And then again, there's a corresponding definition for the negatives, okay? There's like a bunch of corresponding definitions, right? We could approach a from the right. If this is negative infinity, then we just replace this with a negative infinity, and all of these definitions kind of spawn from the same one. As kind of like some little subtleties, if you really get into the technical aspect, technically if a limit, technically this case, the limit doesn't exist. We write that it equals infinity, but technically it doesn't exist at all. All right, and that's probably not ever going to come up in this class. But for anyone, this could come up in a future class. So to be really technically precise, that's what's going on here. We're just describing the behavior. Mathematicians use this phrase called abusive notation, all right? We're slightly abusing the notation here even though it doesn't technically equal infinity. Infinity is not a number. Something cannot equal infinity because it's not a number. But it still describes what we're talking about really well. And again, if you do look into, 2.5, this is not 2.5. If you do look into section 2.5 with the definition, the formal definition of a limit, you're going to see why it can't really equal infinity this way, and that's a different definition. But we won't deal with that too much. All right, let's do example 6 to reinforce this concept, and then move on to asymptotes. Use a table to find the limits, and then check your answers with graphs. We haven't used a lot of tables since the first video. This will be good practice. All right, for f of x equals 1 over x. That is a weird, there we go. Part A. What is the limit? As x approaches 0 from the left of this function. So let's make our table. Okay. Let's look at x's from the left and function values. This one you can actually do by hand. Right? To the left of 0, this is a number that's close to 0. Negative 0.1. And then we can get even closer to 0 and even closer to 0. Right? These are all getting closer to 0 from the left, just like before in the first video of this section. And I say you can do this by hand because this is the reciprocal function. What's the reciprocal of negative 1/10? Right? That's negative 1/10. The reciprocal, flip it upside down. The reciprocal is negative 10. What's the reciprocal of negative 1/100th? Negative 100. And so on. This next one's going to be negative 1,000. And if we kept on going with this pattern, what is this function doing? As x is getting close to 0 from the left, this function shooting down to negative infinity. Okay, so we're going to say the limit as x approaches 0 of this function, as x approaches 0 from the left, is negative infinity. Technically, the limit doesn't exist, but we write that it equals negative infinity. And in fact, I'm not actually going to take the time to do it right now, but you can pause the video. I'll give you the answer afterwards. Pause the video, find the limit as x approaches 0 from the right of this function. It's going to be almost exactly the same calculations, just positive. So pause the video, and I'll spoil the answer. It's positive infinity. So from the left is negative infinity. From the right is positive infinity. So if I asked you a part C, hypothetically, said what's the limit as x goes to 0 of this function? Well, it's got a different limit on the right and a different limit on the left. We're going to say this limit does not exist. If they both equaled positive infinity, we'd say it's positive infinity. If they both equaled negative infinity, we'd say it was negative infinity. But again, these are not the same. So we're going to say the two-sided limit doesn't exist. Just like that earlier example over here. All right. That's limits at infinity. Let's talk a little bit about asymptotes. Again, you may have seen this a little bit. I know I've taught it a little bit in my pre-calculus class. We have a theorem that says if n is some positive number, and if it's even as well, if n is positive and even, then the limit as x approaches some number a of 1 over x minus a to the n equals something. Well, if x is approaching a, right? This denominator is getting really close to 0. This is a vertical asymptote. Denominator is getting really close to 0. So if we divide by something really, really small, right? If we divide by something really, really small, we get something really, really big. Is it going to be positive or negative? It's going to approach infinity. It's a vertical asymptote. But is it positive infinity or negative infinity? Well, if n is even, this denominator is always positive, right? If we're squaring something, it's positive. Raise it to the 4th power, it's positive. This whole thing has to always be positive, so it is equal to positive infinity, just like we have written. But if n is odd, then we have to talk about one-sided limits. If n is odd, this same limit from the left is going to be something, and the limit from the right is also going to be something. And again, let's think about this. If we're looking at x is a little to the left, x is to the left of a, x is smaller than a, what does this look like? If x is a little bit smaller, then we're subtracting something bigger, and this is going to be negative. Because n is odd, so the n doesn't actually have anything to do with it. So this is one will go off to negative infinity. And if x is a little bigger, then it's positive, and it'll go off to positive infinity. So if n is odd, the two-sided limit doesn't exist, just like over here. Oh, we were supposed to check our answers for example 6 with a graph. Let's do that real quick. This is a reciprocal function. So from the left, shooting down to negative infinity. From the right, going up to positive infinity, and the two-sided limit doesn't exist. All right. All right, and you can see a bunch of aspects of this. Let's just plug in, let's just visually look at this. Let's look at x minus, it doesn't matter what number we choose. If it's to an even exponent, 2, 4, 6, it's always going to be positive infinity, right? But if it's an odd exponent, then it's negative infinity on the left and positive infinity on the right. And again, it doesn't matter what odd exponent we have. Even, both going to positive infinity. Odd, depends on what side. As a side note, we also had this assumption. If n is positive, well, what happens if n is negative? If n is negative, it's not a rational function anymore. It's, well, technically it is. It's a polynomial, right? Negative exponents flip it. So this is the exact same thing as just x minus 1 to the positive 3. This cubic function, these are the same functions. That's why we have the assumption that n is positive, because if n is negative, then we're really not dealing with this asymptote situation at all. Okay. So the last thing to include here that I kind of talked about in these cases, part of this theorem, there's a vertical asymptote. Where's that vertical asymptote? At x equals a. Remember, asymptotes are always the equation of lines. So a vertical line is x equals. Vertical asymptote is x equals. A horizontal line would be a line y equals. So a horizontal asymptote would have that form. And there are also slant asymptotes, which have the equation of diagonal lines. We're not going to talk about that too much here. Last part of this video, and then we'll be basically done with the section. Example 7. Evaluate these limits at a glance. No table, no graph, although you could use a table or graph to check your answers. Let's look at the limit as x approaches -3 from the left, from the left, of the function 1 divided by x plus 3 to the 4th. So let's start by noting, right? Noting that this function is the right form for us to use that theorem from the last page, right? 1 divided by x minus some number to a positive exponent. And specifically, this positive exponent is even. So at the location of the discontinuity, at the location of the vertical asymptote, -3, we know that the two-sided limit is positive infinity. Well, if the two-sided limit's positive infinity, what's the one-sided limit going to be? Has to also be positive infinity. As soon as you know a two-sided limit, you know both one-sided limits are the same. As soon as you know a two-sided limit, both one-sided limits are the same. That's this blue box here. If and only if. If the one-sided limits are the same, that's a two-sided limit, and vice versa. Okay? Let's do part B. The limit as x approaches -3. Well, now it's asking about the two-sided limit. We already answered that. Again, the two-sided limit is positive infinity from that theorem in the last page. Let's look at a different point, different function. The two-sided limit as x approaches 2 of 1 divided by x minus 2 cubed. So now we have a slightly different situation, right? We're still looking at the asymptote, right? X equals 2 is the location of the vertical asymptote for this function. So, but now n is odd. So if it's odd, that says from the left it's negative, from the right it's positive infinity. We're asking about the two-sided limit here. So for the left it's negative infinity, from the right it's positive infinity. But if that's not the same thing, I keep writing an equal sign, it doesn't equal anything. This doesn't exist. Right? It's negative infinity from the left and positive infinity from the right. That's how we can kind of apply a bunch of different topics. Last thing for this video, I just want to show these ones that we've talked about. If we look at the function 1 over x plus 3 to the 4th, and we were asked, what is the limit from the left? Well, the limit from the left, yes, it's positive infinity. Part B asked for the two-sided limit. Again, at this vertical asymptote, the function's going to positive infinity. So the two-sided limit is also positive infinity. That was our answer for part B. The last function was 1 over x minus 2 cubed. And it said, what is the two-sided limit at x equals 2? Well, from the left, it's negative infinity. From the right, it's positive infinity. So there is no two-sided limit. The limit for part C did not exist. That's the visual representation of what we talked about here. Let me know if you have any questions. You should be all geared up and ready to go for this section's homework. And let me know if you have any questions. I will do one more video doing selected homework problems if you want to see me actually doing the homework problems. Okay? So, bye-bye.